All right, these are the answers to the horizontal and vertical. On this first one, we see a vertical line, so it has a slope that's undefined. And when we do an undefined thing like that, if you look at all these points, they all have one thing in common. This is 3, 1, this is 3, 2, this is 3, negative 1, 3, 0. When you look at all those points, the one thing they all have in common is the x values are all 3. And so that's actually what the equation is. It's all points where x equals 3. So if you ever get saved, you know like it's supposed to be x equal or y equal and you forget, just pick some points and see which one is the consistent. Same thing here. We have a horizontal line, has a slope of 0. And if I pick some points, this is going to be 0, negative 4. This point over here is 6, negative 4. This point back here is negative 6, negative 4. All of them have one thing in common, and that's y equals negative 4. Okay. Another way of remembering this is which axis did it hit? It hit the x-axis at 3. X equals 3. This one hit the y-axis at negative 4. So y equals negative 4. Another way to think about it, so like when I get to here and it says graph the line y equal 3, I could either make a table of values with 3 as the y-coordinate for all of them, 0, 1, 2, and go plot those points, or I can just go to the y-axis and go to 3, and then draw my line straight across. Right? Either way gets the job done. For something like this, we have to divide by 6 first. So I divide, I get x equal to negative 4. All right, and then if I go down negative 4, 1, 2, 3, negative 4, there's my, oh, except it's x. So again, I can even make that little mistake there, right? 1, 2, 3, negative 4. Run my line vertical through there, not horizontal. Okay? So again, it's not bad. You just got to kind of remember. So like here, write an equation for a horizontal line that goes through 5, negative 7. If you wanted to, you could kind of plot that 5, negative 7 horizontal line. Hits down the y-axis at negative 7. So it would be y equal negative 7. Okay, horizontal lines, slope is 0, y equal. Right equation for a vertical line that goes through negative 2, negative 9. So if I go negative 2, negative 9 and do a vertical line, I'm hitting the x-axis at negative 2. So x equals negative 2. Right. Which statement about these lines below are true? So if I had this one, if I were to divide, I'd get y equal negative 4. That's a horizontal line. So A says the line 4y minus is horizontal. That is true. So A is true. 3x equal 27. If I divide by 3, I get x equal to 9. That's a vertical line at 9. 3x is vertical. That's true. For both lines, all points on the line have an x and a y coordinate. So that's kind of an odd statement, right? And all it's really saying is that if you pick a point on the line, will you have an x and a y coordinate? Absolutely. Any point you pick on a line will have an x and y coordinate. So it's kind of an odd statement, but that one's true. This one says for either line, one of the coordinates of all the points is always the same value. And so what that means is that if you look at a line and you look at all the coordinates, will one of those coordinates be the same for all of them? And we said that earlier, yeah, that if you look at that line, all of the x's will equal something or all the y's will equal something. So in this case here, it just happens that all of those statements happen to be true. Okay. Number 8 says write an equation for a line that goes through the point 2, negative 3, and 2, negative 9. So if you were to plot that 2, negative 3, 2, 9, draw it. You're drawing a vertical line. It hits the x-axis at 2. So x equals 2. All right. Again, not bad, not a lot, but you just can get yourself twisted around. Make sure you have good notes on that.